Natural physics is a concept I developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as my astrophysics research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each.
Greetings, everyone. I'm Leroy Larry. Welcome to Natural Physics Variety Show, live from Costa Rica. Happy and safe Spring Equinox 2024 to you and your families. Hello, August. Hi, August. Hold up? Let's see. Can you hear me? I can hear you. Let's see. Is the volume coming in okay?
Yeah.
And I got yours good too. All right. Hey, Juliet. Hi. How you doing? Okay. Can you hear me okay?
Yeah.
Okay. Wow, I don't know why, but the audio is sounding kind of jerky, but I think we're okay though. We'll keep rocking and rolling. Wow, it's great to see you. Great to see all of y'all. Wow. It's been a little while.
Yeah.
Now, I tell you, today is the spring equinox. So what I thought we would do, I thought we'd do a show. Okay? And now we're using my my Zoom account. So I got Hey Sarah, how you doing?
Hello.
Hello. Hey,
How are you, Leroy?
doing? All right. How you doing?
I'm doing well, thank you.
Great, 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 great. This is awesome. And oh, I wanted to say before we get started, beautiful pictures that Bruce Callow posted of you receiving the family from Ukraine. Wow, that awesome, awesome pictures in the video. That was
Yeah,
excellent.
it's so exciting.
Wow, I could tell. Oh my goodness, my goodness. Oh, okay. All right. So, oh, look who showed up. Somebody wants to say hi. Sorry, she says I'm talking too loud.
No, I said he was yelling.
Hi,
Hey,
Linda.
borrow your hat. Your hat here today. Hey, Sarah, how's it going, guys?
Good.
Oh, look who's that little Juliet. Hi, baby girl. Did the two sister come to your house?
Yeah, few of them.
4
Oh
times,
my-
Juliet. I took 4.
Oh my goodness.
Wow.
Wow. I bet you really want something crunchy soon. Okay, you guys have a good class.
Thanks, babe. Okay. All right. So, okay. Now, August. Welcome to today, Spring Equinox 2024. And I want to start off by saying Happy New Year.
Happy New Year to you too.
And you might be wondering, why is he telling me Happy New Year? This is March. It's the spring equinox, right? We've actually already talked before on both of our birthdays last month. So why is he wishing me a Happy New Year? Well, August, there's ancient civilizations that actually their New Year's Day was the spring equinox. Okay, when spring equinox occurred, that was the beginning of their new year. Not January the 1st, like we do now, but spring equinox. And we'll talk about that a little bit later in the show. Okay, so I'll just say this. Greetings, everyone. Happy and safe Spring Equinox 2024 to you and your families. This is our natural physics variety show. My guest today for our special spring equinox show, I seem to be having problems saying equinox. My special guest today for our spring equinox show is August, who many of you, hey, August, hey, many of you may remember him. I'm sure you do from when we did our broadcast when we were doing the podcast. So we're back. Yeah. And okay, August. So tell me now, what is it that you understand about the spring equinox? Oh, and by the way, as always, you can ask me any question whatsoever. Okay, any question any question at all. Okay, so tell me, what is it that you think about when you hear spring equinox?
Time change.
What is that?
Time change.
Yeah, that's right, huh? Springtime comes in, the time changes. That's a great answer. Yeah. That's awesome. Well, okay. Now, August, because of the way the Earth orbits the sun, and did you know that the Earth is actually tilted as it orbits the sun? You knew that, right? On. Yeah, okay. So that combined with the way the Earth orbits the sun, it causes these four big events in nature, right? The first one, spring equinox, today, okay? That's when you have an equal day and an equal night. And I'm sure you already knew this, didn't you? Okay. Anytime I start telling you something you already know, just say, Leroy, I know this. Please move on, please. Okay? All right. Okay. So, all right then. Well, then you already know what it's about. Okay. Now, and you know, of course, about the solstices as well. Now, imagine, August, that the reason those phenomena occur is because of a certain force that occurs in nature. Could you, by chance, the reason why the Earth goes around the sun and the moon goes around the Earth?
Gravity.
What's that?
Gravity.
Right on, August. Yes, excellent, excellent, excellent. The force of gravity. Okay, now that is the force that we encounter every day, right? On an everyday basis. And August, you've seen these two videos before, but it's kind of a review because in physics, astrophysics, we're going to be talking about forces, the forces that are involved in stars being born and galaxies evolving. So force, it's a very, very important concept in physics. So I want to show these videos featuring Oscar Balwandini. You've seen them before, but a lot of people will not have seen these. But it's a good, I think it's a fun way to introduce force to people. So,
Oh, okay, brother. Down, I'm out. I'm down. You won, brother.
Got you, little brother.
Yep.
The force U is equal to my mass times my acceleration.
Is that why you're able to spin? Oh, yep, spin me around so fast?
That's right, little brother.
Aha. So acceleration, oh, yep, that's speed. That's fast. That's rapid, right?
That's right, little brother, and I got a lot of acceleration.
Oh, wow, and that force, that just means because you have a lot of mass. You're a big brother.
You got it, Deanie. You got it, little brother.
F equals ma.
Excellent. Excellent, brother. And once again, what does that stand for?
Force equals mass times acceleration.
Excellent. Very excellent, little brother.
And that's an equation.
Hello there. I'm Osco, Balo's big brother and Deanie's big brother. I'm the original natural physics saber-tooth tiger. My weight on this toilet seat is equal to my mass times gravity. And the weight of my tinkle tinkle is equal to its mass times gravity. Good job, little man. Good job, little man. My little brothers talked about how force is equal to mass times acceleration. Your weight is the force that your mass through gravity applies to the earth. Just like the equation for force is F is equal to ma, the equation for weight is W is equal to mg. The weight of my plop plop fizz fizz is equal to its mass times gravity.
You're smart.
Good job, little man. Oh, okay. That wasn't the most graceful dismount, but that'll do, huh, bud? All right, little man, good job. All right, buddy boy.
All right, were you able to see the whole thing?
Yep.
Excellent, excellent, excellent. All right. And for everybody out there watching, yeah, that was from a previous show that August and I did together. And it was so much fun. And it was a review for August, but for the rest of everybody, force is equal to mass times acceleration. That is a fundamental equation in physics, everyone. Okay? And August and I, we're going to be going through physics together uh, and having fun. And we're going to be participating as members of the FAT Pack, right? FAT, P-H-A-T, physics with attitude, enjoying physics as the window into our amazing world of nature and mathematics as the tool to open that window. And as you saw in those equations that Osco, Balo, and Dini used, there's equations in physics that describe the force of gravity that we encounter on a daily basis, and also the same force of gravity, which is the reason why we have the equinox today, the solstices, the upcoming eclipse, right? That's going to be coming up next month. Hey, and by the way, August, do you have any questions for me uh, at this point at all? Okay, interject anytime, but hey, we're hanging out.
Uh,
It's
I do
spring equinox.
actually. You know
Yes.
how you asked me on my birthday to try the equation of how fast the green comet is going? I actually didn't figure it out, but are you able to tell me?
Okay. Yes. Okay. Now, I went on Google. I mean, you can basically ask. I mean, the internet is the world's largest library at your fingertips. It's amazing. So I Googled where is C2022 E3 ZTF, right? The green comet. And I tell you what, I could do, let's try doing screen share again, and I'll show you what I mean. And as I bring up these screens, I'll talk and I'll ask you if you can hear me. Okay, so yeah, let's get real professional. Okay, there we go. It says, as you can see my screen, right? It says it's 854,233,721 kilometers from Earth. Okay. Can you see that, August?
Yeah, far.
Okay. Now, so that's way far, right? 854 million kilometers from Earth. Now, I also I was curious about how fast it was going, right?
Yeah.
Actually, let me go back to this. You know what? Okay. Again, you can Google how fast it's going, and it gives you different answers, which I understand. When it was the closer it got to the sun, the more it picked up velocity. And then as it got further away from the sun, it started slowing down. So it had a range of velocities, but just to get an average velocity, this is what we can do. It says right here that it's 854,233,721 kilometers from Earth. So it's, let's just say it's been gone a year, right? 1 year, 365 days, right? So what we need to do is we need to divide this number, 854,233,721 kilometers, by the amount of seconds in a year, and that will tell us how, on the average, how fast it's been going. So, okay, let's just Google this and make it easy. How many seconds are there in a year? How many seconds are in a year? Okay, there's 31 million 536,000 seconds in 1 year. Okay. Now, the way you get that number, by the way, August, is there's 365 days in a year. Okay. There's 24 hours in each day. There's 60 minutes in each hour. And then there's 60 seconds in each minute. So to get this number here, you'd have to multiply 365 times 24 times 60 times 60. I'm gonna make sure I got that right. 365 days, 24 hours to a day, 65 hours. Wait a minute. 365 days, 24 hours, 60 minutes to an hour, 60 seconds to a minute. Yeah, okay. Okay. So you multiply those numbers together. 365 times 24 times 60 times 60, and it'll give you this number. All right, so what we're going to do is we're going to divide this number into where the comet is now. So we're going to divide 854,233,721 And we're going to divide that by this number, which is the number of seconds in a year. Okay.
27.807573594.
Okay. So let me see. Let me just, okay. So repeat that, please. 27.
27.08
Uh-huh.
757 six
Okay.
five.
Okay. Hey, okay, August. Awesome. You know what? We'll round this off. We're gonna round this off to
27.
yes, exactly. So on average, the green comet, since it left Earth to where it is now, has been traveling at about 30 kilometers per second. Okay. Okay, very cool. Did that answer your question, August?
Yep.
All right. All right. I'm gonna close these windows up and I'm gonna stop sharing. Oh, all right. Okay. Um, okay. All right. Do you have any questions that you would like to ask me, August? Okay. So you understand about the equinoxes and the solstices? Okay, great. And for everyone out there that some of you may wonder, spring equinox and fall equinox, the day and the night are equal amounts of time. Whereas with the winter solstice, you have the longest night of the year, the shortest day. And with the summer solstice, you have the longest day and the shortest night. And all of that is because of what's the force of nature, August, that is responsible for that? Gravity, yes. I don't know why I didn't hear your gravity. Could you say it? I saw you say it, but could you say it one more time? One more. It's I want to clear gravity. What is it now? See, you went like gravity. Okay, we're gonna say it real slow.
Gravity.
There we go. I wanted everybody to hear you say gravity, okay? Because on my end, I guess my connection or something, you were saying grab and then petite and petite. So I wanted everybody to hear you say gravity. Right on, August. Okay. Um, I wanted to go back to saying about the ancient cultures and how some of them actually called spring equinox their first day of the year. And August, because the spring equinox heralds in springtime, why do you think it was so important for the ancient civilizations to know when spring started? What do you think? What what happens in the springtime with
To know when to plant your seeds.
there you go. There you go, August. Exactly. The springtime is the time of the year to plant crops, right? So important to getting food and survival. So, yes, I mean, without a doubt, it's so important. Uh, and so there are ancient cultures that left evidence of how important it was for them to know when spring started. One example I want to tell you about, and this may be somewhat of a review for you. We've talked about so much. I hope I'm not repeating myself, but there's going to be people that are listening and viewing for the first time. So, okay, in the southern part of Costa Rica, there's the territory of the Baduca, the indigenous Baduca people. And they have spheres located on in their territory that no one knows really who, when, why, and especially how they were constructed. But specifically, two of these spheres are oriented east and west. Can you see those, August?
Yep.
Okay, they're oriented east and west to the horizon. And it's such that on equinox, spring equinox, whatever date that might be, today it was March the 19th. Last year, I think it was March the 21st, but every year on the spring equinox, the sun comes up right on the horizon on the morning of spring equinox. So the Barukas, they were able to know exactly when, or I said Badukas, but whoever built these spheres, right? That were, this civilization predated the Badukas. So whoever built these spheres, this would tell them when springtime started. I think you've seen this picture before. This is Tirza and I at the side of the sphere, and you've seen pictures of me with the sphere, and they're huge, right? So when the sun came up on the horizon and it was in line with those two spheres, and fortunately, they're still in where they were originally built and placed. So many of the spheres have been removed, so their original locations are not known, but these are still there. So luckily for us, we have an indicator that these ancient peoples, whoever they were, it was very important for them to know when spring started, right? Today.
Yeah,
Yeah, right? How cool is that, August? Huh?
that's super cool.
Isn't it? Isn't it? I mean, that somebody thousands of years ago, that was their way of knowing, okay, now it's time to plant the crops. Now it's time to get ready to do all the planting and everything so we have food, and understanding nature and the movement. I mean, think about it, August. Whoever did that, that means that they really had a good idea of the motion of the sun, right? The
Yeah,
motion of the sun. And if they knew that, they probably had a really good idea of the motion of the moon. So
yeah,
these people, they were able to keep track of the sun and the moon, which, oh, what do you get from that? You calendar, right? I mean, you can make a calendar when you know all that. You can predict like the solar eclipse that's coming up next month. You can predict that. August, you realize that there is a major total eclipse coming up next month. And it's going to be total only in certain locations. Good at
we
this.
won't be able to see it though.
No, yeah, see, there's the path that it's going, that it's going to go across North America. Um, I'm way down here in Costa Rica, like further down off the, yeah, Costa Rica's right there. And then you're up in Canada. So the people that are going to be able to see it in the United States, here's a, let's see if I can get a, yeah, here's a picture of, okay, there in the United States, you got Northern California, Nevada, Utah, Colorado, some Kansas, Oklahoma, Arkansas, Mississippi, Alabama, and then down to Florida and then out into the ocean. People in Cuba aren't going to be able to see it. Haiti and the Dominican Republic will be able to see it. So, yeah, that's the shadow as the moon comes between the earth and the sun. That's the shadow that the moon will take across the United States. And but we will. I'm going to exit this, stop share screen. We will be able
I
to see.
think that was actually 2020. I mean, 2045, not 2024.
I'm sorry. What did you say?
That one was the August one, not the April one.
Oh, the April one. That's the one I'm talking about.
Yeah, but the picture you're showing was the one on 2045.
Oh, well, you know what? Let me go and check that, August. Awesome. My goodness, dude. Excellent observation capabilities, August. My goodness gracious. Thank you so much. Wow. And you're actually paying attention to what I'm showing. I couldn't be so happier. Okay, all right. Okay, let's find one for the one that's
2024.
okay. You know what? So let me okay, here's what we're gonna do. We're gonna man, August, that was the most excellent catch. Most excellent catch. I am thoroughly impressed. Okay, there we go. Solar eclipse of April 2024. Okay, there we go. Path. Let's see. Let's see what, okay, here we go. All right, so let's do, oh, there's a, okay, so this one, you can see the difference. This one is coming up from the south, starts in Mexico and then Texas, Arkansas, um, Mississippi, Kentucky borderline, Indiana, Ohio, New York, Maine, yeah, New England, and then on out into the ocean. So, yeah, again, me being down here and see if we can find a bigger map, but me being down here in Costa Rica and you being up in Canada, yeah, neither one of us. Oh, here's a big one. There's a big map right there. So I'm way down here and you're way up there. So, yeah. However, we will see the effects of it because the last, okay, I'm gonna stop sharing screen. Yeah, I'm getting pretty good with this. Okay, so, all right. So you can see me now, right?
Yeah.
Okay, the last total solar eclipse, even though we couldn't see it here, do you remember what the last solar eclipse was, August? Total?
No.
Okay, hold up for a second. Let me just
Gosh.
share. Okay,
Australia or something?
what's that?
Wasn't it like Australia or something? Like by
Yeah,
that area?
oh, total. Oh, you know what? Here we go. When this is how awesome the internet is. When was the last total solar eclipse? Okay, 1979. But no, there was no, that's not right. Okay, okay, great eclipse. There was one more recent than that. Great eclipse. Was it 27?
2023.
Was it 27? There we go. This is when I'm okay. The solar eclipse of August 21st, 2017, dubbed the Great American Eclipse, was a total solar eclipse visible within a band that spanned the United States from the Pacific to the Atlantic. Okay, so 2017, that was the last time. And here's the surface area of the United States that it uh, path. It went from Northern California down. You can see the path on the map. So yeah. Now the reason why I'm referring, so yeah, it went through California and these different states, Nevada, Nebraska, Missouri, yeah, on out into the ocean. Uh, the reason why, August, I'm referring to this particular eclipse was because here in Costa Rica, we still saw the effects of it. I mean, part of the sun was obscured by the moon. It wasn't a total solar eclipse. And by all means, we didn't look at it with our naked eyes. We used special eyewear, but
Holding glasses.
yeah, it got dark. It got really creepy. I mean, it's a it's a really cool phenomena. I've never experienced a total solar eclipse. I hope to at some point. But yeah, even though you could see how far we were in Costa Rica from the path of the eclipse in 2017, but we could still see the effects. So the one that's coming up in April, I expect same thing. You, us down here, even though it won't be a total eclipse, we'll be able to see the difference in the lighting, uh, the shades of color, and yeah, it's really cool. It's really cool.
The last time me and my family saw a solar eclipse was, I think it was 2017.
Yeah,
Uh, we went over to my grandparents, and then my grandpa has a big welding glasses, so
yes,
all of us put those on, and then we just looked up.
yes, exactly. Yeah, yeah. That's cool that you said that because in 2017, one of our neighbors had a welding mask, just like what you're saying, and that's what uh we used to look at it. Yeah, that oh yeah. And it's just so cool to witness that. And again, think about back to those ancient civilizations where it was so important to know when spring started and they knew the motion of the moon and the sun. And it's just very amazing that thousands of years ago, these peoples they had their ability to keep track of the motion of the moon and the sun, isn't it?
Yeah, that's so cool.
It's so cool. It's and how'd they do that? They didn't have telescopes. I mean, how they
We just have rocks.
yes rocks. They just had that's a that's one of the quotes of all time. All they had were rocks. Definitely, August. I mean, it's amazing. And So, okay, we're going to talk more about this as we continue on in our shows. And uh, now, one thing I wanted to let you know about is that I now have the opportunity to go back to my astrophysics research. Okay. Yes. Now, do you know about the James Webb Space Telescope?
Yeah.
Okay, I'm gonna do a share screen again. Okay, here we go. I'm gonna share screen now. Okay, August. Okay, this, uh, if this would go away, I can't get to, there we go. Okay, now, you know about the Hubble Space Telescope, right?
Yeah.
Okay, all right. Now, this is one of the most amazing photographs that the Hubble Space Telescope took, right? It was launched in 1990. And look at all those galaxies, August. I mean, and think about our own galaxy, how huge it is, right? I mean, and then you think about our solar system, how huge our solar system is
Yeah.
compared to the Earth, right? So these are you see, there's one that looks like a spiral galaxy, which our Milky Way galaxy is theorized to be in the shape of. August, I don't know if I can even describe the distances that you're looking at here in outer space. I mean, okay, here's a spiral galaxy. Uh, there's elliptical galaxies. That looks like an elliptical galaxy. There's ones that look like nebula. It's just, look at all those galaxies. And
Yeah.
yeah, and every one of those galaxies is as big or bigger or maybe smaller than our galaxy. And our galaxy is huge, right? It's just immense. So you're looking, and that's just a very small section of the sky that the Hubble looked at to take this photograph. It's kind of like if you had a photograph that was 1 meter by 1 meter square, this here photograph would be like a little bitty square centimeter, or not square nanometer. I mean, just a very small part of what's out there. And look at all those galaxies, and they're beautiful. I mean, there's a spiral, looks like bluish in color. There's an elliptical. Oh my goodness, right? So this is the Hubble, the amazing Hubble telescope that enabled us to look so far into outer space. Okay, now I'm gonna get rid of this one. Now here is a photograph from, okay, go away window. This, okay, I'm trying to, okay, okay, this one. Okay, here we go. No, that looks like the same Hubble. Okay, how do I get this window to go away? Let's see here. Go away. Okay, you know what? I know what I'll do. Okay, I'll move it. There we go. Okay. Now, August, this image is from the James Webb Space Telescope, which was launched, get this. You probably already know this. It was launched on Christmas Day. You know what? I'm sorry. Let me do one thing. Okay, escape. Let me just close this. Uh I didn't give the Hubble justice. There was a little arrow down here that said, expand. And so again, take another look at this. This is the Hubble Space Telescope. It made observations in the optical range, the range that we see in, right? And also a little bit of the infrared, which is heat, like ovens, a little bit of that range. But I'm sorry, go ahead, August.
I was just agreeing with you.
Yeah, think you were agreeing or disagreeing?
Yeah, I was agreeing.
Woo! I got worried there. Yeah. So yeah, Hubble mainly optical, right? I mean, just beautiful. And I
Yeah,
mean, these objects, August. We talk about the fact that some of these objects, you're looking back into time. You're looking at millions and millions and millions of years ago, because that's how long it took light traveling at the speed of light to reach us. That's traveling that fast. I'm sorry, go ahead, August.
I'm just agreeing with you.
Yeah. And now, August, can I ask you this? Do you know what the velocity of light is?
No.
Okay. Now, I think it is about, this is what I'm gonna do, because okay, so I'm doing screen share. I guess I never stopped it. That's okay. I'm gonna stop this and I'm just gonna go speed of light. I believe it's 310,000 kilometers per second. But let's see, speed of light in kilometers per second. Yeah, okay, 300 on, just round it out. Um, about 300,000 kilometers per second. Okay, 300,000, and the speed of light in miles per second is 186,000 miles per second. But okay, speed of light, 300,000 kilometers per second. Okay, so back to our diagram here, our beautiful picture. Okay, traveling at a speed of 300,000 kilometers per second. Some of these objects are millions and millions of years. They're millions and millions. It took light millions and millions of years to get to us. That's how far they are away, August. I mean, it's the distances are unimaginable, to be honest about it, right? And the thing of it is, some of the stars that you see at night, they're not there any longer because they're so far away that they blew up and disappeared millions of years ago, but it took so long for the light to get to us from them that even though they
Yeah,
blew up and yeah, disappeared, the light is still coming to us and we still see them. So the same thing with these galaxies. So, okay, this is the beautiful picture of the Hubble. Now, 1990, it was launched. It's been doing magnificent observations since 1990. Now we're going to go to the new generation James Webb Space Telescope. Okay, which is able to see even further, August, than the Hubble, right? Now, the Webb Space Telescope sees in the infrared as opposed to the optical, but that's okay because it's able to see things that the Hubble could not see because of dust particles and different obstructions in outer space. So the infrared range, it has that extra ability to see things. And the discoveries that this telescope is going to make, August, are going to be phenomenal. I mean, think about Hubble, what amazing discoveries it made. The Webb Space Telescope is going to do even more. It's just going to make mind-boggling discoveries. What you're looking at are galaxies that are even further out than the photograph that I showed you from Hubble. Unbelievable, right? And again, yeah, and it's just in a small, very small section of the sky. I mean, again, there's a spiral galaxy right there. We got an elliptical right there. Okay, we got a kind of like a nebula there. Just beautiful, just amazing. And there's another spiral, and each one of those galaxies is like our Milky Way galaxy, August. And think about how many stars are in our Milky Way galaxy, and then think about how many planets are orbiting these stars, and that just gives you an idea, August, of just the unconceivable number of galaxies and stellar systems and planets that are out there. My goodness. I mean, it's just unreal. So
Yeah.
I'm gonna stop sharing screen here. Let's see, I'm gonna escape. Okay, I'm gonna stop share. Okay, so here's my big announcement. What happened to my picture? Hello. Uh,
Your video is off.
oh, I need to turn my video on. Okay.
Yeah.
Speaker. Let me see here. Start video. Okay, here we go. All right. Okay, so now how do we get side by side like we were a gallery? There we go. Okay, I'm back. All right, so those pictures, August, what do you think? What do you think about that? Huh?
Those are cool.
Aren't they? I mean, what can you say to how huge outer space is? I mean, and okay. Sorry, I gotta do this. Okay, I'm gonna do share screen. Now, I want to show you. Okay, let me just. Okay, so our Milky Way galaxy, August. Okay, I'm just gonna type in width. I think it's 310,000 light years, but width of Milky. Okay, width of Milky Way galaxy across about 100,000 light years, August. Okay, our Milky Way galaxy is 100,000 light years across. And a light year was what? It was 300,000 kilometers. Okay, right? Yeah, a light year was 300,000 kilometers. So our Milky Way galaxy is about 100,000 light years. So if you multiply 100,000 by 300,000, let me make sure I'm doing this right. A light year is 300,000 kilometers. So yeah, if you multiply 100,000 by 300,000 in kilometers, that's how wide our Milky Way galaxy is. That's
Yeah,
huge,
that's
isn't it? Isn't it?
crazy big.
Huh?
That's crazy big.
Yes, yes, that is. That's huge, right? That's huge. So every one of these galaxies every one of these galaxies, can you see that, August?
No.
Okay, because I need to do a screen share. Okay, that's okay. All right, I got a little, thought I could, okay, share. Okay, now you can see it, right?
Yeah.
Okay, so every one of those galaxies, August, could be as big as our galaxy, right?
Yeah.
100,000 times 300,000 kilometers, right? Or bigger or smaller, but huge, huge. And the number of stellar systems like our solar system and the number of planets, oh, it's inconceivable. So, okay. So now I so much appreciate you hanging out with me on spring equinox. Very special. And I don't want to take up you and your family's time, but let me, first of all, I have an announcement to make. And then, but before I do, actually, let me go ahead and make my announcement. So, the James Webb Space Telescope, that image that I showed, okay, get this, August. It was launched on Christmas Day, 2021, right? Great energy, right? December 25th, 2021, it got launched up, right? Cape Canaveral, Cape Kennedy, Florida, right? So it started operations in July of 2022. And that image I showed you, that was one of the first images that was released to the public of what it had taken. Very first observation. In fact, the United States, um, the president of the United States released it in a like a press conference because it was a big deal, right? The very first image from the James Webb Space Telescope, showing us even further out in outer space than the Hubble did, right? And what's so cool is people will be able to put the two together, the data that the Hubble has been getting and the data that the Webb is going to get, and put them together. Oh wow, what's going to be discovered? Uh, August is unbelievable. So August, I said to myself, I want to be a part of this. How do I become a part of this? I'm not a member of a space project at NASA right now. I was, but not now. I'm not a member of um, I'm not a student at a university, right? Doing research. How do I become a part? How can I become a part of these amazing discoveries that are going to happen? Huh? How do I do that? How do I do that? How do I do it? August, I found out that okay, wow, it says we're running out of time. That's okay. We're good. The James Webb Space Telescope, and we'll talk more about this in our next show. It has a website where the data is gathered, right? From nebula, from black holes, from quasars, from neutron stars, August. Data, real data. Now, the research group that gathers the data, they have 1 year to, look at their data, analyze it, make their discoveries before it becomes available to the public. And that's fair, right? I mean, it wouldn't be cool to get some observations and have data for a world shaking discovery. And then somebody comes along and, oh, this is cool. Da-da-da-da. Hey, look what I, all right? That wouldn't be cool. So it's cool that the research groups have a whole year to look at their data and do what they can with it, after which the public can. Now, you need the appropriate computer. I'm going to have a computer made to handle the data. And then I have to learn the software and the data analysis tools. But what I want you and people to know out there, that every show, I want you to feel like you're right there with me as I start doing my research, right? I have I have to identify a research topic, okay? Do I want to study how stars were born? Do I want to study how galaxies were born? Do I want to study what happened after the Big Bang? Do I want to study exoplanets where life might exist? So it's possible now, modern technology, August, The Webb telescope data is available to the public. You can get your data, you can analyze it, and you can make your own discoveries, right? How cool is that? Huh? So,
That's super cool.
okay, so as I get my deal together and put it together and all that, again, I'm gonna keep everybody updated. We'll figure out our next show. Did you have any more questions at all about equinox, solstice, anything like that? Any questions at all?
Yes, when's the next not solar eclipse, when's the next lunar eclipse?
Okay, okay, I'm gonna do a share screen. Do a share screen here. Share. Okay, so I'm gonna minimize this. Okay, your question was, okay, is when is the next lunar, right?
Yeah, lunar.
Okay, when is the next lunar eclipse? Okay. Wow, a year from now? March 13th, 2025? Wow, that's a lot. Okay, let's do this. Let's see, when is the next partial uh lunar eclipse? Let's see here. Uh okay,
September 18th.
September 18th, 2014, partial lunar eclipse. And those are cool too. I mean, I'm gonna stop sharing. I mean, even if it's a partial solar eclipse or a partial lunar eclipse, they're still amazingly beautiful. Uh, I mean, it's nature. And again, it's the force of nature, gravity, that's doing all that. And have you ever got to see a total solar or lunar eclipse, August? Yeah, me neither. Not yet. But we got plenty of time and they'll be coming around the bend. So hey, we'll have to do that. Um, all right. Well, any questions, and not necessarily about Equinox or any of that. Okay. So my plan, August, is that we're going to continue hanging out like this. We'll get a definite schedule set up that's good, and we'll just keep talking about physics. And now you understand the part that the force of gravity plays in, just like with Oscar Balloondini, right? With Oscar's plop plop fizz fizz, right? And his tinkle tinkle, right? The gravity of the earth on that. And with Balo twirling his little brother Dini around, the force he exerted on him. So the forces in nature, August, we're going to be talking about that because again, it's our way of trying to understand what we perceive in nature. It's fact, physics with attitude. Okay. All right. So well, if we don't have any more questions, then we'll figure out a good schedule, right, to do. And you know what? If you want to, you know already, if you want to put together questions for me and email me anytime, you can do so. But we will have a show and we'll just keep talking physics. Are you okay? Let me ask you this, and please be honest. So far, are you having fun with physics? Excellent, excellent. Because a lot of people, they think physics is not that exciting. And when you talk about mathematical equations, that really gets them, oh, no, no, no. But what we're going to show on our show, August, is how beautiful it is that you have mathematical equations that help us get a look inside to nature and gravity and the planets and the earth and the moon and the sun. So, okay, thank you for, do you want to say anything in closing? Oh, by the way, that was so much fun hanging out on my birthday and your birthday. That was most excellent. Most
Yeah,
excellent. Yeah.
it
Hey,
was
so okay. Uh uh do you have anything you want to say in closing?
no.
Uh okay. Okay, cool. So, all right. So I will wind down the show. Everybody out there listening and viewing, thank you for joining us. Keep an eye and an ear out for our next show. I certainly hope August will be joining me. I mean, I can't ask for a by the way, August, what we want to do too is get where if you want to invite anybody to join in to ask me questions, right? We can do that, right? Anybody that wants to come on, they can do that, join in, and we're just gonna take it where it goes and have fun doing it. Okay? All right.